Welcome back to Maths in an Empty Classroom with me, Mr. Sutton. This is part 3 of the lesson on projectiles, and in this video I'm going to be looking at projectile at an angle where we're given slightly different information, slightly different problem to solve. So here we have a particle is projected at 45 meters per second from a point O on a horizontal plane. The maximum height it reaches is 40 meters, and we're being asked to find the angle of projection and the range of the particle. So I'm just going to begin by drawing out what's going on here. So I'm going to have my horizontal plane here, and then I'm going to have the projectile, which is from a fixed point on a horizontal plane, so it's going to look like so. We'll call that the point O, and it is projected initially at a speed of 45 meters per second. So we'll label that as 45. And we're also told that the greatest height the particle reaches is 40 meters, so we'll just label that in there as 40 meters. And what I'm also just going to do, just so we don't get confused with what's going on here, is I'm just going to make that line start and finish at the end of the diagram, just so it makes more sense. Right, okay, so we've been given projection at an angle. We don't know the angle, so I'm just going to label it in here as theta. So what I'm just going to do for making it neat is I'm just going to do the components of that initial velocity here. So we've got the vertical component, which is going to be 45 sine theta, and then we've got the horizontal component, which is going to be 45 cos theta. And again, split your page in 2 columns, horizontal, vertical, write down what we know to start with and see how we can get to a solution on this one. So we'll start off horizontally. We have that our initial velocity in the x direction is 45 cos theta. We know that the acceleration is 0. We don't know the time, we don't know the displacement, and so at the moment that's all we've got horizontally. So looking vertically then, we have our initial velocity in the y direction vertically is 45 sine theta. We have our acceleration, which is due to gravity, is negative 9.8, and we know that the displacement in the y direction is 40 meters. So I've got a bit of information that I can work from here. We also know that given this is the greatest height that the particle reaches, we know that the velocity in the y direction here is going to equal 0 because it's on its way up and then it's coming back down again. So at the greatest height, the velocity is 0. Works the same way in projectiles as it does in vertical motion. I mean, vertical motion is essentially projectiles anyway, just directly up and down. So what we're going to do over on the right hand side then is we're going to add in the fact that we know that Vy is equal to 0, because that means I'm going to be able to use the that equation v squared equals u squared plus 2as, because I have all that information available to me. So v is 0, u is 45 sine theta, so I'm going to make sure I put that in a bracket, all squared, plus 2, acceleration is negative 9.8, and s is 40, and it's positive 40, because it's 40 meters above where it started. So what that's going to mean is if I do 45 sine theta squared, so I'm going to need to square the 45 as well as the sine theta. So I'm going to have 2025 sine squared theta, or sine theta squared. Is going to equal 784, which is 2 times negative 9.8 times 40, and then add it over. So this is going to give me enough information to work out the angle, because what I can now say is I can say that sine squared theta, or sine theta squared, is equal to 784 over 2025. and these are beautiful square numbers, so when I square root, sine theta is going to be 28 over 45. I don't need to worry about the plus or minus here because I'm looking for the principal value of sine, which is going to be the inverse of the positive root. Okay, so 28 over 45. And what I can now do is I can do sine inverse in degrees mode of 28 over 45, which is going to tell me that the angle theta to 3 significant figures, I'll do a few decimal places first, 4, 7, 8. So to 3 significant figures, the angle is 38.5 degrees. Now, just an interesting point here is that because we've now got sine theta equals 28 over 45, if you think about what sine theta equals, it's opposite over hypotenuse. Well, the hypotenuse of this is 45, which means that this vertical component of velocity actually is 28. It is exactly 28 metres per second in the vertical direction. Okay, so what we are now looking for is the range of the particle, which is the total distance travelled here. We're going to need quite a bit of information to work this one out. We're going to need to know the time that we got to this point here, and then we're going to need to use the horizontal component. So I'm still working vertically to start with, and I'm going to try and find out the time. And to do that, I'm going to be using V equals U plus AT, with V as 0. U is 45 sine theta, but because it's the vertical component, I now know that that is exactly 28 plus A, which is negative 9.8 T. And if I solve that equation there, I get that T is 20 over 7. Now, crucially, let's just think about where on our diagram that time 20 over 7 is happening. Well, it's here. It's at this point here. So T equals 20 over 7 is the halfway point because we've gone up and we've come back down again. That means if I double the time to T equals 40 over 7, I'm going to find the total time that the particle took to go from O and get back to the ground again. And that's what I need to find the range of the particle, because I'm going to need to do the speed horizontally multiplied by the time. So if I just go here on the left-hand side, my displacement in the x direction, my range, is going to be 45 cos theta multiplied by the time, which is 40 over 7. Now I've still got the value of theta in my calculator from when I solved it down there, so I'm just going to use that, do cos of that, multiply by 45, and multiply by 40 over 7 to get that the range of the particle is 201.301, which to 3 significant figures is 201 metres. So that is the range of the particle there. Okay. So key things from this example then, we were thinking horizontally, vertically. We knew the vertical displacement and we knew that the vertical velocity at that point had to be 0 because the particle was at its greatest height. From there we were able to work out the angle of projection, the time at which it was that point, which we could then double because this was the halfway point on the journey. And once we knew the total time, finding the distance horizontally is very easy because we can just do speed times time. I'll see you in the next video.